If you want to learn how to optimize your Roblox game, then look no further. In this video, we'll be exploring tons of ways to optimize your game and squeeze out as much performance as possible, especially for your mobile players. And speaking of exploring, let's explore and learn about today's sponsor, Brilliant. Brilliant is an online learning platform designed to make you a better thinker and problem solver. They have thousands of lectures across a variety of subjects such as math, science, programming, data analysis, and artificial intelligence. Each lesson is interactive and contains hands-on problem solving, allowing you to experiment and play with concepts instead of watching boring lecture videos. This style of learning is extremely effective, which allows Brilliant to help you build your understanding from the ground up. You'll start off on the basics of concepts and work your way up as Brilliant keeps track of your progress and places increasingly challenging problems in your way to make sure you're still learning. As programmers, we often neglect to understand the lower level processes of computers and how they transform our code into usable instructions. But thanks to Brilliant's new Digital Circuits course, you can gain an incredible understanding of how logic gates work, which are one of the fundamental components used to perform logical operations within a processor. I've already started going through the Digital Circuits course, and I love how incredibly interactive and simple it is to learn about the millions of logic gates working behind the scenes in our everyday devices. To get started with Brilliant, you can go to brilliant.org/crushyourfire or scan the QR code on screen to get 30 days absolutely free. You'll also get 20% off an annual premium subscription. Thanks to Brilliant for sponsoring this video. One of the first areas of optimization we're going to be taking a look at is how to improve the memory usage in your experience. And a really easy way to improve memory usage in your experience is by checking if you have high memory usage regarding collisions in your game. So if we read the Roblox documentation, physics movement and collision detection consumes memory. Mesh parts, along with constructive solid geometry parts, have a collision fidelity property that determines the approach that used to evaluate the collision bounds of the mesh. The default and precise collision detection modes consumes significantly more memory than the other two modes with lower fidelity collision shapes. If you see high levels of memory consumption under physics parts, you might need to explore reducing the collision fidelity of objects in your experience. So inside of a basic default template baseplate, if we open the developer console by hitting F9 on our keyboard, and then we open this tab right here and go to memory, and then we go and shift this or organize this by high memory usage by clicking this. And then we're going to skip over this core memory area because we don't care about any of this internal stuff. We just want to go down until we find the place memory category right here. And the one we're going to be specifically looking for is physics parts, this one right here. Because this is a basic template or a base plate, there are no meshes, no parts in this place. So the physics part memory is at 1 megabyte, which is just probably for my player's character, and that's it. Once you start building your map and you add more unions and you add in meshes and all that stuff, this value will slowly start to increase, and you can fight back against how much memory usage goes under this category by reducing the collision fidelity of meshes and unions in your game. For example, here in this game that I'm in, it's a project that I've been working on, you can see that the physics parts memory usage is at about 420 megabytes. The higher and higher this value gets, let's say you get close to 1,000 megabytes or you go over 1,000 megabytes, you might want to start worrying about how much memory usage is being used for collisions in your game. And a way to improve the value here is by going around to all the meshes and unions in your game and checking their collision fidelity. There's an easy way to do this, a really easy way to do this. If you go to this little thingy in the top right corner, this little settings cog, and you open that up, you should be able to find somewhere in here called collision fidelity under physics simulation. So if you enable that, you're going to see that your map turns a whole bunch of crazy colors if you have a bunch of meshes. Otherwise, if you have regular parts, they won't change. But this specifically colors all of the unions and meshes in your game. Now, the more colors you see means the higher resolution this collision is on, for example, this door truck. So if we go down to collision, there's going to be a property here called collision fidelity. Right now it's set to default for this truck door. And default, along with PreciseConvexDecomposition, these ones take up the most memory usage. The ones that take up the least memory usage is going to be box and hole. And as the name suggests for box, it literally just creates a bounding box collision fidelity around the object. It's literally just a box, and then whole kind of, you can imagine it as like a saran wrap or a shrink wrap, shrinking around the object. These two options are what you want to try and aim for most of the time because they use the least amount of memory. And if you take a look at my map, you can see I have a lot of these box collisions on, for example, these are light poles. Now, because these light poles actually have collisions disabled on them, I disabled the can collide property. There's no reason for me to be storing a bunch of information about the collision of the light pole when nothing can collide with it. So I just set the collision fidelity to box. I believe it's locked right now, so let me see if I can actually find it, or maybe pick a different object. For example, right here. Just by looking at this box, you probably wouldn't be able to figure out what this is. But if we disable collision fidelity, you can see it's a fire hydrant. Now, right now, fire hydrants have all their collisions disabled. And because they have all their collisions disabled, it doesn't really make any sense for me to store a whole bunch of information about the collision fidelity of the fire hydrant. Like if I set it to default, you can see there's a lot of information being stored on here on the collision of the fire hydrant, which I don't need because you can't collide with it. So I set the collision fidelity to box, which takes up the least amount of memory usage. And when you take a look around my map, you can see I've made a lot of these optimizations all over the place. You can see tons of boxes all over the place. You can also see these shapes in the distance here, these meshes or these mountains, and these have their collision fidelity set to whole, and you can kind of see how it's like a shrink wrap effect over the object. This one uses the second least amount of memory usage. The box one's the best, but if you can't use the box one because it just doesn't work for the shapes you want, let me see if there's a good example I could find. Like for example, if you take a look at these buttons here, these buttons are kind of semi-cylindrical, but I don't really want to have them set to box. Well, actually, they have their collision set to nothing, so it probably makes sense to set them to box. Let me see if I can find a better example. I believe there's a trash can in here somewhere. Here it is. Okay, we have a trash can that players can collide with. Now, because the trash can is cylindrical, right, it doesn't make sense for it to have a box collision group. Because if I were to set it to box, you got these corners sticking out here, and players would collide with these corners, and that would be kind of weird to have a trash can like this with that kind of boxy collision. So that's why you have the whole option for collision fidelity. It's pretty good for cylindrical objects, spheres, stuff like that. You just set it to that and it does a pretty good job of shrink wrapping around it and using very little memory. Let me see if I can find any other example. For example, here's a triangle. This is just some kind of prop. Technically, I could make this have no collision at all and then set the collision fidelity to box, but for some reason, let's say you have some triangle shaped thing in your game that you want players to be able to collide with. If we take a look at this thing, that's what that is. If we were to set the collision fidelity to default, you're gonna see that's a lot of information being stored for a triangle. And if we were to set to box, that's maybe not the collision that we want on the triangle. So whole is the best option for this one. The Explorer makes it really easy to search for any objects in your game that have different collision fidelities, because all you need to do is search for the property collision fidelity equal to, and then it'll pop up with all the options. So maybe you want to see if there's anything in your game that has the PreciseConvexDecomposition, and in my game there's nothing, which is great. If you have a bunch of meshes or unions in your game that has this property enabled, see if you can change the collision fidelity to something a bit simpler. And if the object is super complex and you need complex collision, then you probably would rather have the object be completely non-collidable, set the collision fidelity to box, and then manually construct your own collision fidelity just using parts. That would be a lot better for memory usage and performance instead of using the precise option. Another memory optimization that we can take a look at is this category for sounds. If you notice that the value here in megabytes is extremely high for sounds, let's say you have like 500 megabytes of memory being used for sounds for some reason, that means you have way too many sounds in your game that are loaded and just sitting around and doing nothing. Typically this happens if you have a whole bunch of stuff in the sound service. So let's say you store all of your game sounds inside of the sound service in different folders and stuff. You have all the music in your game, all the ambiance, all the sound effects as sound objects. Well, the problem with doing it that way, by having a whole bunch of sound instances in here with sound IDs, is that all of these sound instances and the sounds inside of them need to be stored inside of memory. They need to be downloaded and then they need to be stored in memory. That's kind of a waste, especially most of the time sounds are just sitting in the sound service not being played, and they only play at specific moments. So what's better? What's better is to not store any sounds in the sound service and instead store your sounds inside of your scripts. So basically just have the content ID or the sound ID for your sound, and then create the sound during runtime, play the sound when you need it, and then destroy it or clean it up afterwards when you don't need it anymore. As an example, I have a whole bunch of utility functions that I use to play sounds, and I do so by just giving it a table of sound properties. So this can be like the volume, the sound ID, if it belongs to a sound group or whatever it is. And then it plays it, and then when the sound is done playing, it destroys it for me. So that way I'm only creating and loading the sounds into memory when I need them, play them when I need them, and then clean them up afterwards. You can see that inside of this game, my sounds memory usage is only at about 58 megabytes because I don't have a bunch of sound instances stored in sound service. I have them stored, or I have their sound IDs stored inside of scripts. I create the sounds when I need them, and then when I don't need them anymore, then, that's it, I destroy them. When you open this thing up too as well, you could also see all of the sound instances that are currently loaded into memory and how much memory they take up, which is also pretty cool. So this can help you narrow down like, hey, which sounds are taking up a lot of memory, and figure out, do I really need to store this sound inside of the sound service or inside of some object somewhere? And instead, can I just create it during runtime and then only play it when I need it? Along with storing sounds in the sound service, you should also make determinations of whether you need something to be stored in replicated storage or if it can be stored inside of server storage. A lot of the times there are instances or objects that you can move out of replicated storage and store in server storage. For example, let's say your game has a bunch of maps. Let's say you got 10 different maps on your game and the server loads different maps at different times. Realistically, a client doesn't need to have all 10 of those maps in a folder stored in replicated storage because it needs to reserve memory to store information about all the instances and everything in those maps. If those maps are only supposed to show up at a certain point in your game, then you should probably store them in server storage. By storing objects inside of server storage, you're preventing the clients from having to store all of that information inside of memory, along with having to download it when they join the game, which can also improve your loading times. Another way of improving memory usage is by cleaning up connections connected to player instances and their character models. So inside of the workspace, if we go to the properties window, there's going to be a property down here called PlayerCharacterDestroyBehavior. You should probably have this set to enabled. The default is default, and I don't know if the default is enabled, but you probably just want to make sure this is set to enabled. Because the prior behavior with players and their character models is that when a character model dies or the player left the game, their instance would only be parented to nil, but the destroy function would not be called on the character models or the player models. So if you had any connections to any events to the player or anything inside of the character model, stuff like that, those connections would sit around in memory. And as more and more players join the game, leave the game, spawn and respawn, you would have a bunch of memory leaks and building up of memory in your game till eventually maybe your server would crash and then you'd have to get a new server and start the process all over again. So it's just a good idea to have this player character destroy behavior set to enabled. The next area we're going to be taking a look at improving is going to be this graphics texture category. If you have very high memory usage, let's say you have like 500 megabytes or more, 1000 megabytes, whatever it is for graphics texture, you really need to ask yourself, do I need those high resolution 1024 by 1024 pixel textures on multiple different objects with all their own unique textures? Or am I able to downsize those textures to something smaller, like 512 by 512 pixels? And can I use things like texture atlases? And can I use things such as, I believe they're called, what are they called? Trim sheets, texture trim sheets. There's a bunch of little hacky things that people can do with textures to be able to reuse them across multiple objects and keep this memory usage down. So that way you're not having to have a bunch of client memory usage being wasted because you decided to upload super high resolution textures. In fact, if we look at the documentation, it says a 1024 by 1024 pixel texture consumes 4 times 4 times the graphics memory of a 512 by 512 texture. Images uploaded to Roblox are transcoded to a fixed format, so there is no memory benefit to uploading images in a color model associated with fewer bytes per pixel. Similarly, compressing images prior to upload or removing the alpha channel from images that don't need it can decrease image size on disk, but either doesn't improve or only minimally improves memory usage. So as I said, if you can downsize or scale down your textures, do it. If you can use texture atlases, do it. If you can use trim sheets, do it. This will help save memory usage in relation to the graphics texture category for your game. Another incredibly important feature inside of the Roblox game engine is going to be streaming enabled. Right now I don't have it enabled in this game, but when you enable this allows you to stream in and out objects inside of the workspace, which can help improve load times and reduce memory usage. I'm not going to go into everything about streaming enabled. That can be a video on its own that would probably be like 20 minutes long. So I'm not going to go into it. This will probably be a future video, but I will leave a link in the description to the Roblox documentation all about streaming enabled. The next area we're going to be taking a look at improving performance is going to be frame rate. And what's the easiest way you could do that? Well, the easiest way you could do that is by reducing the number of draw calls happening every single frame. So inside of Studio, if you opened this statistics menu by hitting Control Shift, and I believe it is, what is it, F2? Yes, F2, Control Shift F2, you get this menu popping open. And what we're interested in is this thing down here that says draw counts. And the one that we're most interested in is going to be this scene draw count. So Mr. Chicken Rocket recommends that you should have a budget of 500 in-scene draw counts and about 500,000 triangles. I'm a little bit above that, 590,000 triangles, but I am below the 500 draw call count budget. If you have this number or this value of scene draw counts in the thousands, you've got a problem, and you need to optimize your game to figure out how to make sure your draw counts don't go above 1,000 or 500 or something like that. Usually it's okay to go above 500, but 500 is a good metric to hit, especially for mobile devices. Now, Roblox did introduce their Occlusion Culling feature. So when the camera blocks objects from view, you're going to notice that the scene draw counts reduce because I'm not rendering a bunch of stuff. Like if I put my camera into a wall, you can see that the draw counts reduce, and as I look around at other stuff, you can see that they increase because I'm having to draw more meshes and triangles and things like that. We could actually see this in action. Let me see if I can find if it's in here. Yes, wireframe. Let's go into wireframe mode. So here we can see all the triangles being rendered, and if I look inside of a wall, you're going to notice that very few things are being rendered, except for some reason there's a fountain over there being rendered, which is kind of interesting. Character NPC models also don't get culled by the Occlusion Culling, and for some reason grass doesn't either, which is pretty interesting. Another thing that doesn't get culled by Occlusion Culling are particle emitters and beams, and I believe trails as well. You can see those trails moving, and they don't seem to be getting culled. And the crazy thing about particle emitters and beams is that each particle emitter and each beam takes one draw call, even if they use the same texture. Because typically when you have a mesh, for example, this light post here, because these light posts all use the same mesh IDs, they all get batched into a single draw call. So even if I were to look at 100 of these light poles in a scene, it only takes one draw call to draw all of the light poles, which is pretty cool. Unfortunately, that doesn't happen with particle emitters or beams. They don't get culled by Occlusion Culling, so that means you're kind of left to do it yourself or suffer the consequences. For example, here are some particles, and here are some beams being rendered on screen. Now, I have a system in place, my ClientFidelity service, which I made a video on, you could check it out, where once the camera or the character gets far enough away from these beams or particle emitters, I cull them or I disable them so they're not being rendered. Because realistically, if, let's say I'm all the way over here, let me teleport all the way over here, there's no reason why I should be rendering that. And actually, you could notice that they disappeared. They're not being rendered anymore because I'm too far away. I'm too far away to notice or care about those beams or particle emitters. So why do I need to render them? So I disable them. I also do the same thing for lights in my game as well. You can see when I walk away, you can see those lights getting disabled and things like that. And if I open the settings of my game and I disable high graphics fidelity, I also disable shadows and global shadows, which also helps with the shadow draw count. Though the shadow draw count is still pretty high because if I go to my lighting service, I am in the future lighting technology. If you set this to shadow map and you disable global shadows, you're going to have 0 draw counts, which is really good for mobile players because they don't have to waste time rendering shadows. And do mobile players really care about shadows? I don't know. I think mobile players would actually rather care about the game being playable instead of it running 2 frames per second. That's just my opinion. So as you can see over there, I have more particle emitters, beams, and even some decals over there, slightly transparent decals. And by the way, if you have a whole bunch of transparent textures overlapping each other, that can cause something called high transparency overdraw, which is also not great for performance. But because I'm on low fidelity mode and I go and I walk away from these decals, eventually, boom, they all disappear. They get cold, they get disabled, and that helps reduce the amount of draw counts happening and also helps disable the issue or mitigate the issue with the high transparency overdraw with those transparent decals because they aren't being rendered. Now, usually the culprit of a very high draw count is either one of 2 things that I've seen. One is that you have way too many unique meshes in your game, and for some reason you might have the same meshes but with different mesh IDs, which are being batched into separate draw calls, which are increasing your draw call count. Or you have a bunch of particle emitters in your game all over the map that are enabled that aren't being culled and they're just being rendered. It's probably one of those 2 things. As an example, if you take a look at this foliage, I have some dead trees and I have some trees with leaves. Now, these trees were actually imported as separate meshes. So originally, this mesh right here, despite it being the exact same mesh as this one, they're both literally the exact same. They both had different mesh IDs. Their mesh IDs were different. And because of that, that means instead of these being batched into the same draw call, these were being batched into 2 separate draw calls, which isn't great. So I went in and fixed that by replacing all of the, I think it was the dead trees. I replaced all the dead trees to have the same mesh ID as the alive trees. And that fixed that draw call issue. Another example I could give you are these shipping containers over here. So if you take a look at these shipping containers, not only do we have the body of the shipping container, but we have 4 doors. And you know what's interesting about these 4 doors? Well, they're all the same mesh, except for the fact that they have like flipped hinges. So technically, I should only need 2 draw calls, one for the left door and one for the right door. But because these were imported with all the doors on them, each door had its own unique mesh ID. So I needed to fix that as well by just reusing the same doors over here and then moving them over here and flipping them. And that reduced my draw calls for the shipping containers by 50%. Those are things that you just need to watch out for when you're importing meshes. Let me give you another example. There should be a truck around here somewhere. Let me find a truck. This guy should have a truck. Why is it, where'd the truck go? There were trucks here and now they're gone, which is actually quite interesting. That's kind of weird. Can I find a different truck somewhere? I'm gonna have to fix that. Okay, here, look, there's a truck over here. If we look at these wheels on the truck, right? They're literally the exact same mesh. They're just flipped around. And then with the rear tires, these are both the exact same meshes. But because this truck was imported together with all the wheels on them, each wheel or each tire has its own unique mesh ID. So if we look at this one, so the mesh ID ends in 714. And if we look at this one, the mesh ID ends in 505. So look at that. This is something I need to fix because these tires are the exact same, but they're being batched into 2 separate draw calls. Not great. The more and more meshes you add into the game that have these kind of issues, the more and more your draw calls will pile up, and eventually you're going to have to fix it. Another area of frame rate optimization you might want to take a peek at for your meshes is going to be a property called RenderFidelity. Now typically you'll want to have this fidelity set to automatic, or you could set it to performance on certain meshes, though setting it to performance might alter the visual look of meshes in some cases. So you might need to play around with these properties and see if performance would work. Otherwise, automatic should work for most cases. Now, if you have a bunch of meshes in your game that have their render fidelity set to precise for some reason, you probably want to set it to automatic. Because if we go and we search in my game, render fidelity equals 2, and we check to see if there's any meshes with precise. Actually, we do have some meshes with precise, which I'll probably want to change and disable. Otherwise, the default meshes in here that are set to precise are probably character models. I think it's only character models that have the render fidelity set to precise. But as you can see, there's some meshes here in regards to this card scanner. So I want to make sure all of these meshes are set to automatic instead of precise, because if I'm super far away, there's no reason for me to be precisely rendering the mesh. If we look in the Roblox documentation under the meshes section, there's a level of detail category, and it says you can dynamically control a mesh's level of detail using its enum render fidelity property. The default value is automatic, meaning the mesh's detail is based on its distance from the camera as outlined in the following table. So this is an LOD system for meshes. If you're less than 250 studs away from the camera, then it renders it in the highest fidelity. If you're about 250 to 500 studs away, then it renders it in medium fidelity, and when you're greater than 500 studs away, the mesh is rendered in the lowest fidelity. And you can kind of see how it gets decomposed over time as the rendering becomes less precise. Probably the amount of triangles gets reduced automatically through some internal engine operation. But just having all of your meshes set to automatic should be good for most cases. If there's a way for you to set the level of detail to, or the rendering fidelity to performance, push as much performance as possible, then you can totally do that. However, it says this means that the performance will always be excellent, but mesh visuals may be affected negatively, so you need to kind of experiment with this. Another area you can make with performance improvements are humanoids. So if I take a look at one of these humanoids, this is a static NPC. He doesn't move around, he can't move around, he just stands there and you talk to the NPC. Now, because of this, it doesn't make sense for the humanoid to be calculating all of its different states, because humanoids have a bunch of different states like running, sitting, falling down, getting up, jumping, all that kind of stuff. Why does the humanoid need to evaluate for all those different states when it's a static NPC? So what's the smart thing to do with your static NPCs that have humanoids in them? Go over to the humanoid properties and disable evaluate state machine. By disabling the state machine, you are now no longer wasting CPU time calculating all of the stuff for the humanoid. Now, if you do need to have your humanoids move around, but let's say they only walk around, they don't jump, they don't climb, they can't fall over, then you can also go through and disable certain humanoid states, so that way you're not calculating those either. By going through and disabling certain humanoid states that you're never going to use, that will also help improve performance with your humanoids. Another area of performance improvement is when you have a lot of moving objects in your game that you're updating every single frame. So if you look, I have all of these spinners spinning in this kind of obby area. I've got those spinners, I got these shark spinners, they're all spinning around. Now these are actually being C-frame updated on the client side for every single client. And then they're all synced together by using a timestamp of when the spinner was initialized on the server side. So that way all the clients have their spinners synced up so they look the same across clients. But all of these spinners are having their C-frames updated every single frame. Now, if you were to do that individually, and let's say you had hundreds or thousands of these parts in your game, that can take up a lot of CPU time. So a way you can fix that is by using bulk C-frame updates using a method in the workspace. If I go down to the command bar here, there's a method in here called BulkMoveTo. Moves a table of base parts to a table of C-frames. And by using this method, it allows you to update the C-frame properties of a crap ton of parts really quickly. So inside of my code, every single heartbeat, I'm running this obby spinner update. And I go through all the spinners in my game and I calculate the correct C-frame. I get this new C-frame, and then I simply insert it into a parts table and a C-frames table. And then once I've gone through all the spinners in my game, then I do a single bulk move to update on all of the parts with their associated C-frames. And that's a lot faster if I were to, instead of doing bulk move to, I were to go in here. I know I'm in testing mode, I can't make any changes. If I were to do spinner.cframe is equal to new C-frame, and I just did that for every single spinner, this will actually take longer than instead of just doing bulk move to. If we open up the micro profiler, and then I were to pause the microprofiler, and then let me select some random frame in here like this one, and then let's find heartbeat. There's heartbeat. There's also another heartbeat down here. If we go down into heartbeat, there's my obby spinner update right there, and it's taking approximately 0.36 milliseconds to update all of the spinners inside of my obby. Not bad. Now I've got a new idea. Let's go ahead and comment this code out. Let's comment this code out. Let's comment this code out. And instead of doing the bulk update, let's just do spinner.cframe is equal to new cframe. And let's see how much of a difference that makes to the frame time. So we'll go ahead and pause the microprofiler. We'll select the random frame in here like this one. And then there we go. Here's our obby spinner update. And it is now taking 0.49 milliseconds instead of the 0.3 something milliseconds. You might be thinking, that wasn't a lot. And that's right, because there's not that many spinners being updated in here. But when you have a crap ton of parts that you need to update simultaneously, let's say on a per frame basis, or maybe even just once, using BulkMoveTo over individually setting all of the C frames can be a game changer. And let's actually see if we can improve the performance further with BulkMoveTo by specifying a specific event mode. So let me uncomment that, uncomment that, uncomment this. And there's a third parameter we could pass here called bulk move mode. So we could do enum bulk move mode. And instead of firing all events, which I believe is the default for this function, let's just fire CFrame changed. And this should also hopefully improve BulkMoveTo even further. Let's go ahead and pause. Let's pick a random frame. And then here is our obby spinner update. How long did that take? Look at that. It took even less time by just firing the CFrame changed event. 0.255 milliseconds. So we went from 0.49 down to 0.255 just by using BulkMoveTo. And when you have a lot of objects in your game, that about 50% performance improvement can really add up. Now there are a couple more properties inside of the workspace that you'll likely benefit from enabling. So if we go back into the workspace, there's going to be a property in here called ClientAnimatorThrottling. Make sure you have that enabled. Basically what this property does is that the farther away an animator instance is away from the player's character or camera or something like that, it'll update that animation at a slower rate. So it'll only do like intermittent updates to the animation when it's far away because you can't really see it. And any animators that are nearby to your camera or your character will be updated at their normal rate. And this can also just help boost performance a little bit with animators. Another property is going to be called PhysicsSteppingMethod, and this will be set to default by default. If you set it to the adaptive mode, this allows the engine to make some decisions on how it wants to do some physics calculations, and it reduces a certain amount of physics calculations, basically just improves performance in regards to physics. So you probably want to have this set to adaptive. The last area of optimization we're going to be focusing on is networking. And specifically, we're going to be taking a look at this incoming or overall incoming network data in kilobytes per second. Now, a good baseline, as Mr. Chicken Rocket noted, is that you want to have this value below 50 kilobytes per second on a consistent basis. If you see that your overall incoming kilobytes per second is above 50 kilobytes per second, that likely means you have way too many assemblies in your game that the server is having to replicate. Now, an assembly is basically an unanchored conglomeration of physics, so things attached together with physics constraints like welds that are unanchored with some unanchored point, or you have character models connected together with motor 60s, or you have different physics constraints like hinges and things like that. When you have tons of those things in your game, the high incoming network usage with Roblox physics kind of makes it hard to work with, especially if you need server-sided validated physics, which hopefully maybe Roblox's server-sided Aurora thing they're working on in the future might fix this problem, but who knows. But you need to make decisions on how many things you want in your game to be unanchored, how many assemblies you have in your game that are moving around, and any optimizations you can make around those assemblies. Like, for example, I could have totally opted to make all of the spinners use physics constraints. I could have had like, I don't know, hinges or something in here and had like forces applied to have these things spinning. that would have tanked, or not tanked, that would have just made my overall incoming kilobytes per second like crazy with all these spinners. It'd probably be over 100 kilobytes per second or something like that. Not good. So when you can figure out ways to not use physics, don't use physics. When it comes to players' character models, that's kind of inevitable because players need to run around. And when you have NPCs in your game, or like AI that the server controls that get moved around, that's kind of another point of friction where you got to figure out, okay, maybe I need to make my own server-sided replication system to control how much data I send over for stuff. It's kind of a complex solution. Basically, you just want to make sure that you reduce the amount of assemblies in your game when possible, like with the spinner example, reduce the amount of unanchored parts in your game. And then if you're able, you could also use IK control instances or inverse kinematics to try and offset the issue with overall incoming network data. And that'll probably be a future video because there's actually something really powerful with inverse kinematics that allows you to animate like objects and make them look like they're using physics or animation or whatever, but it has zero impact on the overall incoming data, which is really cool. I'll make a future video on it, I promise. Otherwise, another point that you have with controlling how much overall incoming data there is your remote events. So let's say you have something very frequently happening in your game where you need to constantly send out data to players. Maybe you can serialize that with buffers. I have an entire video about buffers, and one of the main utilizations of buffers is for your own replication systems for compressing down data. In fact, there's this really awesome dev forum post that talks about how these developers reduced bandwidth usage by 60 times in their game. Because originally their overall bandwidth usage on the incoming was 300 to 350 kilobytes per second. Not good. And the reason why is because they had a bunch of parts on the server that were moving around in humanoids, and because there's so many of those parts moving around as assemblies, that just takes up so much overall bandwidth usage, which is why they had over 300 kilobytes per second. And eventually they came to a point where they decided, hey, we can't do any of this stuff on the server. The server just needs to store positional stuff, and then the clients have to control the visualization of things and linearly interpolate the NPCs and stuff like that. It's a lot of work to fix this kind of replication or bandwidth usage, and it's unfortunately something I'm going to have to do here pretty soon with a system I need to make. Kind of sucks that you have to do it this way, but Roblox does provide the tools with buffers and things like that to be able to actually code a system like this and bring your overall bandwidth usage down from 310 to 4.8 to 5.2, which is crazy. Otherwise, a couple other simple ways to avoid having very high overall incoming data is 1, don't tween on the server. Never tween on the server, don't do that. Number 2, don't play animations on the server side. If you need to play animations, have the clients play the animations. Tell the clients through a remote event or something, hey, I want you to play an animation on this guy, and have the clients do it. Because otherwise, if you play tweens on the server, or you play animations on the server, all of that data has to get replicated to the clients, and that will boost up your overall incoming kilobytes per second. Along with that, making a bunch of C-frame updates on the server also impacts the overall incoming data as well. Because, for example, with these spinners I've got here, I could have totally simulated the C-frame updates for these spinners on the server side. And you know what that would have meant for my overall incoming data? It would have meant disaster, because that would be so many C-frame updates needing to be sent to all the players in the game when I could just have the players simulate the spinners on the client side instead. Now, there's a whole bunch more stuff I could talk about in regards to performance, but that would make this video way too stinking long. So instead, I'm going to leave a whole bunch of resources in the description, such as these articles, dev forum posts to Mr. Chicken Rocket's posts, stuff like that, so you can go ahead and take a look and read through them and see if there's anything that can be of use to you to improve the performance issues in your games. Otherwise, thank you for watching, and I will see you in the next one.